So far, we've defined what it means to write an integer in the exponent. We can write any rational number in the exponent, and we now have the equipment required to define what that means. So remember, for positive integers, x to the n just means multiply together n copies of x. For any real number that's not 0, that number to the 0th power is just 1. And for any real number that's not 0, taking the negative n power means take the reciprocal of the n power. Next, we're going to define rational powers with numerator 1. Right, so x to the power 1 over q, for a fraction 1 over q, right? Q is a positive integer for now. We're going to make this definition thinking of positive integer denominators. And we'd like to define x to the power 1 over q in a way that's consistent with the power of a power rule. Right? So for integers, we had the power of a power rule, x to the n raised to the p power is x to the n times p. So when I raise something to the n power and then to the p power, I can multiply the exponents. To make x to the 1 over q be consistent with this definition, we need to have x to the 1 over q to the q be equal to x to the power 1 over q times q. But 1 over q times q is just 1. We need x to the power 1 over q raised to the q power to give us x back. So x to the 1 over q is the number that, when I raise it to the q power, gives me x. But that was just how we defined the qth root of x. To be consistent with the power of a power rule, we need to define x to the 1 over q to be the qth root of x. And we'll say that that's for any real number x for which this qth root is defined. Right? In other words, if q is even, then x has to be positive or 0. If q is odd, we can have any x. So x to the 1 over q means the qth root of x, and x to the 1 over q is defined wherever the qth root of x is defined.